Okay, number 10. A car has a final speed of 20 meters per second and an acceleration of 2 meters per second squared. If it has been moving for 8 seconds, what was its initial velocity?
Draw a picture!
We've got a car. I think that looks more like a UFO than a car, but whatever. Here, I'll draw a window. I don't think that made it better, but whatever. The car is moving. It's moving that way. So the car started somewhere. So I don't know, I'm just going to call it X naught. That's where the car was, and the car has moved past that. So the car has been moving for a while. Okay, that's about the extent of my picture.
2. Label your nose. Your knowns. Label your knowns.
Now, what do we know from the problem? What does the problem give us? Okay, it says the car has a final speed of 10 meters per second. So my V final equals 20 meters per second. We know the acceleration of the car is 2 meters per second squared. So I'm going to say acceleration is 2 meters per second squared. The problem also tells us how long the car has been moving. So the time that the car has been moving is 8 seconds. Okay?
Wow.
Okay, that's everything we know. What is our target? The problem asks what was the initial speed. So back where it started somewhere. We're asking what speed did this car start from? So V naught equals question mark. That's what we're looking for. Okay, I have everything I know and my target. Now I need an equation with all those things in it. So again, look at the first 3 equations of your equation sheet. Those are the equations you want to use for kinematics problems. So I need my equation to have a V naught in it for sure because that is my target.
Well, all 3 of these have a V naught in it, so that doesn't help us choose an equation.
Okay, so the second and the third equations both have an x and an x naught in them, but we don't know anything about position. We don't have any numbers related to the position of the car. So I can exclude the second and third equations, and I'm left with the first equation. So I'm going to write it out. V equals V naught plus a t.
I have no zeros to plug in.
I'm looking for V naught, so I need to isolate V naught. I need to get our variable by itself. So to get V naught by itself, I'm going to subtract a t on both sides, and I get V final minus a t equals V naught. Boom, I already have my variable isolated. Now I can plug in numbers. V final, 20 meters per second. 20 minus, the acceleration is 2, times the time, which is 8, equals V naught. And I get that V naught equals 4 meters per second. Again, do not forget your units. We are talking about a speed. And a speed is measured in meters per second. If you just put 4, you're going to get it wrong. You must have these units so that we know what you're talking about. Okay, before we present our answer, we have to ask, is this reasonable? So does this make sense? So we're saying the car started with a speed of 4 meters per second, accelerated with a positive acceleration for 8 seconds, and got up to a greater speed of 20 meters per second. That makes sense. If it started with a positive speed, had a positive acceleration, then it's going to get faster. And so this all makes sense. So it makes sense that the initial speed is smaller than the final speed
Because the car was speeding up.
Finally, I'm going to present my answer just by boxing it.